Hi guys, here's the video going over 1.10 Day 2 variation. So with this video you're going to learn variation problems, direct variation, joint variation, and inverse variation. So the first thing we want to do is define those three types of variation. So direct variation is when you're comparing two variables, as one goes up, the other goes up as well. So when you're looking at word problems, you'll see these phrases for direct variation. You'll see varies directly as or directly proportional to. Each type of variation does have its own formula, and for direct variation it is this one right here, y equals kx. And k, which I'm going to go ahead and put in this corner over here to find k is the constant of variation. So for direct variation, it's y equals kx. For inverse variation, what's happening is as one variable goes up, the other variable decreases. And then for the phrases, for the word problems, it'll say varies inversely as or inversely proportional to. And here is your formula for inverse variation. Joint variation is a combination of both direct and inverse variation. Direct variation is going to go in the numerator. Inverse variation is going to go in the denominator. So when we say something varies directly as, that particular value is going to go in the numerator, and if something varies inversely as or indirectly as, that's going to be in the denominator. And here is your formula for joint variation, a combination of both direct and inverse variation. All right, let's go ahead and do an example. So assume that y is directly proportional to x. Use the given x and y values to find a linear model. So x equals 5 and y equals 12. So the first thing I'm going to do is I'm going to write out the formula for direct variation since it says y is directly proportional to x. So I'm going to write this as y equals k times x. Now I do have values for both x and y, so I'm going to go ahead and replace that into my formula. So y is 12 when x is 5. So I have 12 equals k times 5, and then I'm going to use this to solve for k, my constant of variation. So to solve for k, I'm going to divide both sides by 5. I'm going to go ahead and leave this as the fraction 12 fifths. So k equals 12 fifths. So it says use the given x and y values to find a linear model. So your linear model is just your equation. So for your equation, you're going to go back to this, the y equals kx, but you're going to leave x and y as variables. So k is 12 fifths times x. So this right here represents the linear model for the direct variation. For the second example, finding a math model, once again, we're trying to find a mathematical model of variation for these verbal statements. So letter A, it says V varies directly as the cube of E. So normally when you read direct variation, it'll say Y varies directly as X. So Y varies directly as X. So then that would be the equation Y equals KX. So what I'm trying to do is I'm trying to compare these pieces of my sentence to the direct variation. So instead of y, I'm going to put v equals k, and then my x, since it's varying directly to the cube of e, in the spot of x in this equation, I'm going to write the cube of e, also known as e cubed. For inverse variation, same deal. So normally we see y varies inversely as x. So that formula would be y equals k over x. But I'm making adjustments based on what the sentence is saying. So instead of y, I'm going to write h equals k over, and it's varying inversely as the square of x. So I'm going to put x squared in the denominator. And then for letter C, I just realized that this says AAA. It should be A, B, C. For letter C, it says Z varies jointly as the square of x and the cube of y. So when it says varies jointly, the first part, so the square of x, that's going to be your direct variation. And the second part, the cube of y, is going to be your inverse variation. So normally with joint variation, we have y equals kx over z. That's the formula that we had on this page, kx over z. Go back. And then I'm going to put the other parts in for y, x, and z. So instead of y, I have z equals k, and instead of x, I have the square of x, because that's my direct variation. And instead of z, I have the cube of y, because that's my inverse variation. So those are the math models for these verbal statements using variation. The next thing we're going to look at is variation problems within an application, so essentially word problems. So the speed v at which an automobile was traveling before the brakes were applied can sometimes be estimated from the length L of the tire skids. Assume that v is directly proportional to the square root of L. So part A says to express v as a function of L by means of a formula that involves a constant of proportionality k. So we just want to write the model. So I have a v is directly proportional to, so I'm going to write v equals, and since it's direct proportion, it's going to be k times, and in this case, it is the square root of L. So square root of L. Now, when you're dealing with writing the functions, please make sure that you read it very carefully. So this is the square root of L. It's not the square of L, so square root of L. So you need to have the square root. Part B says for a certain automobile on a dry surface, L is 50 feet. When V is 35 miles per hour, find the constant of proportionality. So I'm going to replace my L with 50 feet and my v with 35. So that's going to set up an equation. So I have 35 equals k times the square root of L, which is 50. So it says find the constant of proportionality. So I'm going to write k equals, and then to solve this equation, I would divide both sides by the square root of 50. So k equals 35 over the square root of 50. We can go ahead and leave that as it is. We don't necessarily need to rationalize it. So yeah, go ahead and just leave k as 3 over the square root of 50. And then for letter C, it says estimate the initial speed of an automobile if the tire skid is 150 feet long. So the tire skid is what L is. So I'm going to plug this in for L. So now that I know what k is, I can write my function as v equals 35 over the square root of 50 times the square root of L. So in this case, I have 35 over the square root of 50 times the square root of 150. And I'm going to put that into my calculator. So 35 divided by the square root of 50 times the square root of 150. And that gives you approximately 60.6 miles per hour. So that is how fast that car was going when the tire skid is 150 feet long. All right, let's do another word problem. So for this one, it says a gas law states that the volume of an enclosed gas varies directly as the temperature and inversely as the pressure. So gas varies directly as the temperature and inversely as the pressure. The pressure of the gas is 0.75 kilogram per square centimeter when the temperature is 294 Kelvin and the volume is 8,000 cubic centimeters. Find the pressure when the temperature is 300 Kelvin and the volume is 7,000 cubic centimeters. Whoa, that is a confusing question because there are numbers everywhere. So when you're solving a variation problem, you need to do it in 3 steps. These are actually the 3 steps that you're going to use when you're solving those problems. It's just that with this particular problem, it is not separated into parts. But I'm going to go ahead and pretend like it is separated into parts. Part A for this one was to write a function. So that's what I'm going to do for this one. I'm going to start by writing a function. So I'm going to label this. I want to do the function first. So it says gas varies directly as the temperature and inversely as the pressure. So it's both of them, so that is going to be joint variation. So I'm going to say, oh, it's the volume of gas. Not just gas, volume of gas. That's important. So I'm going to say V equals K, and my direct variation, directly as the temperature. So my temperature, I'm going to put T. And inversely as the pressure, so P on the bottom. So part A is to find a function. Part B, if I go back to my previous problem, part B was to find the constant of proportionality, so to solve for K. So I'm going to go ahead and do that next. So when you're solving for K, the word problem is going to give you pieces of information, and that's what we have right here. We have the pressure of the gas is 0.75 when the temperature is 294 and the volume is 8,000 cubic centimeters. So it'll give you all of the information that you need to plug into all of the variables except for K, because that's what we need to solve for. So my volume was 8,000. The temperature was 294. And the pressure was 0.75. Now, anytime I have a fraction, my brain automatically goes to cross multiplication. So I'm going to cross multiply. So 8,000 times 0.75. 8,000 times 0.75, putting that into my calculator gives us 6,000 equals K times 294. I'm going to divide to find what K is. So K equals 6,000 divided by 294 gives us a decimal. I'm going to go ahead and change it to a fraction, because why not? Gives us 1,000 over 49. Okay, now part C. So if I go back to this, part C was to actually solve a problem. So estimate the initial speed of the automobile if the tire skid is 150 feet long. So you're using the equation and your constant of proportionality to actually solve for something. So for part C, I'm going to rewrite my equation, except for K, I'm going to replace it with that 1,000 over 49. Temperature over pressure. Now, if I look at the rest of the problem, it says find the pressure when the temperature is 3,000 Kelvin and the volume is 7,000 cubic centimeters. So I'm going to go ahead and make some replacements. So my volume was 7,000. K is still 1,000 over 49, but my temperature is 300. And I'm trying to solve for the pressure. So again, I have that fraction, so I'm going to go ahead and cross multiply. So that gives me 7,000 P equals these two. I'm going to go ahead and multiply in my calculator. So 1,000 over 49 times 300 gives me a lovely decimal, which I'm going to go ahead and leave as a decimal since we're getting close to the answer. So let's see, so that is 6,000, wrong color, 6,122.45. Going to divide by 1,000. And the pressure is approximately, I said 1,000, I meant 7,000. The pressure is approximately 0.87, and the units for pressure is kilograms per square centimeter. So kilograms per centimeter squared. So your variation word problems are always a three-step process, even though it is not broken apart into three parts like this question was. But you're going to do the same three parts anyway, so might as well break it apart. So part 1 is to find the function, so that's part A. Part B is to solve for your constant of proportionality, to solve for K. And then part C is to use your K and your equation to actually solve the problem. All right, so that is the end of the video going over variation.